So first thing that you want to do is make sure that the controls are at the correct location. So I move the intensity knob to the center, the focus knob to the center, the trigger level, the hold off to the center. I take the horizontal position to the center. I make sure that the XY button is out. I make sure that both of these coupling and source for the trigger portion are totally up. I look at the vertical position, put it in the center, horizontal position in the center. The variable sweep gets all the way clockwise. I make sure that the center of channel 1, there are actually two knobs here. There's a wider one for the volts per division, and the center one is for the calibration. And I do the same thing on channel 2, make sure that it is fully counterclockwise. Now I can leave this coupling for the channel 1 in the AC position. So that means that if a signal is coming in, I should be able to see it on the oscilloscope. If it's DC only, it's not going to be seen, but this helps me determine if I have some kind of signal there. And the same thing on this side. The channel 2 coupling, put that on AC. The vertical mode, I have that in the top position, the channel 1 position. You will notice that I have two oscilloscope probes connected, so I can run this with two signals. I can run a channel 1 and a channel 2. If I did that, I would put it on dual. And so now when I turn it on, I should have some kind of a trace on my screen. So let's push the button. We'll let it warm up for a little bit, and you'll see, yeah, I do have a flat trace on the screen. So now I can go and adjust it to look pretty. If you run the intensity full blast, you'll see that the line gets very thick. The trace is thick and it's not very accurate. So I usually run it toward the center, maybe a little less. The focus, again, if it's not focused correctly, you see that the beam is very wide. The trace is very wide. As I turn this down, I'm going to get a nice sweet spot where I have a line that is completely sharp. So now that I have the oscilloscope set up, then I want to get it ready for signal to come in. So if I pan over, you'll see that I have the BK precision function generator, and I'm going to connect that up. But before I do that, you'll notice that I'm missing something here on the front. I'm missing the ground connection. Our oscilloscope probes have the ground tab taken off. It would normally clip right into this area here, but we have taken them out because they're really too short to do us much good in lab. Also, another thing I want to check while I have my probes out is if I have it on ×1 or ×10. This particular oscilloscope probe has a switch, and I'll switch it to the ×1. ×1 means that whatever I read here on the vertical axis on the oscilloscope display, that number of divisions multiplied by what I have here set on the volts per division will give me an accurate voltage. If I had this on the ×10, I would have to take whatever value I got here multiplied by the volts per division, and then I'd have to multiply that by 10 to be able to get the accurate voltage level. Now you'll notice that I have attached the ground lead to the ground connection. This is the lead. On the opposite end, I have an alligator clip connected to it. I'm going to connect that to the negative connection of the signal generator, and the positive connection I am going to connect directly to the oscilloscope probe. And you'll see I'm displaying a nice little sine wave. So let's go through a little bit of what we need to do as far as the settings of the oscilloscope. This is not to explain how we use the oscilloscope from scratch. This is just simply to refresh your memory on how the oscilloscope will be used for measurement in lab. So right now that I have this on 2 volts per division, and I'm looking at this, I have 1, 2, 3, 4, a little less than 4 divisions. So I could take 4 times 2 would give me 8 volts peak to peak. But because it's a little bit less on the top and the bottom, I'm actually going to go for about 7.6 volts peak to peak. Now, when the amplitude of the signal changes on the signal generator, you don't see that right now, but I'm moving the amplitude, and it may reach a point to where it's off the screen. In that respect, you need to turn the volts per division down. Now I'm on 5 volts per division. If I wanted to make sure that this was a symmetrical sine wave, in other words, it was the same on the top as it is on the bottom, then I would put this on the ground position, the coupling on the ground position, make sure that it is exactly in the center of the oscilloscope screen, and then put it back up. Now I know that I have an AC signal that is symmetrical coming in. I'm going to do something called DC offset. So if I pan over here, you will see that I have an offset knob next to my amplitude knob. So I'm going to pull that knob out, and that allows me to get a DC offset. You notice that I have it pretty close to maximum negative offset. So when I look on the oscilloscope screen, it has half of the waveform up here and the other half of the waveform below. But see, there's this clipping. That clipping is because we are exceeding the peak-to-peak output of the signal generator. So if I want to see what the DC actually looks like, the DC offset, then I will switch this down to DC. Now here's a good time to talk about trigger, because you'll notice that the waveform just keeps moving across the screen and it is not locked in. One of the things that works best is adjusting the trigger level, and if that doesn't work, I'm going to adjust the hold off. But you see, just by turning the trigger level just a little bit, I've locked the signal in. Now what this is telling me is that, remember, this is 0 volts here at this point, and if I could go about halfway down the signal, this is about how much offset I have. I have 1, 2, 3 divisions approximately, because remember, this down here is clipped. So if I could adjust some things, I would get a smooth sine wave. But I know from looking at it just a second ago that I have 3 divisions of DC voltage. It's at 5 volts per division, so that is an offset of negative 15 volts. So now let me decrease the offset, and you will see what happens. As I decrease it, then this center part will move up. Now when I get to about here, that means that my offset is pretty much 0. And if I pan over to the offset button, you can see that the little pointer is somewhere in the middle. It's off just a little bit. maybe it needs to be adjusted a little bit internally to get it perfect. So now let's look and see what a positive offset would look like. See, as I go positive, it's going to need to be triggered again. There, I adjusted the trigger level. It's locked into place. Now that brings this up. Maybe if I crank it up a little bit more on the trigger level, it'll work. Now see how this is basically cut off up here? That's because the signal generator can only make a certain amount of voltage. So it's about 20 volts peak to peak is what it can make. And we can see 5, 10, 15, 20 volts because there's 4 divisions, there's 5 volts per division. So that is the limitation of the oscilloscope. If I turn down the amplitude, then I could actually get a good offset, but the amplitude is low enough to where it doesn't clip. And again, I want to try to get this to basically stop. Hold off sometimes helps. Trigger level at some point will help. There it is. You see it locked in now. And depending upon the level of signal, that will determine what my trigger level needs to be. So I am at a positive offset at this point. What happens when I turn it from DC to AC is that I put a capacitor in series with the signal, and the capacitor will block out any DC voltage level, which is about half of this point here. So I have about 3.5 divisions. So that's about 17.5 volts right there of offset. But if I switch it to AC, you'll see how all the DC is removed, and we just have the changing part of the signal. That is what the AC coupling does for your input. Again, I'm going to adjust the trigger level till it locks. Now, sometimes you'll have to adjust the trigger level multiple times if you change the signal a lot, if you change its amplitude or its frequency, or even its offset. So I'm going to turn off offset right now. I'm going to go back onto DC, and you will see that the signal is still in the center, still symmetrical above and below the 0 line.